technique that we are going to look at to separate a solid liquid mixture is simple distillation. Okay, so when would we use this simple distillation? It still works on the mixture of solid liquid whereby the solid is soluble. Okay, so we are still looking at a solution. So previously we covered evaporation to dryness, we covered crystallization, okay, and both are used on a solution mixture, okay, whereby the solid is able to dissolve. We are still looking at the same kind of mixture, but why do we use simple distillation over here? It's because what you want to get is different. In evaporation to dryness and crystallization, you want to get the solid. Here, I want to get the liquid. Okay, so you will realize it will not be possible to get the liquid if you attempt to achieve it via evaporation to dryness or crystallization. Those two techniques, you are boiling away the solvent. Then you will have no solvent or hardly any solvent or impure solvent left at the end. Okay, so it doesn't work if you want to get the solvent using those two methods. So we have to make use of another method known as simple distillation to obtain the solvent in this case. So simple distillation gives us the solvent from a solution. Okay, and this is the picture of a simple distillation setup. Okay, so I'm going to use this picture to explain the entire concept to you. We start off with a solid liquid mixture, okay, whereby solid is soluble. The solid is salt and the liquid is water. So the key idea here is we want to get the water, not the salt. Okay, if we want to get the salt, you do evaporation to dryness. I want the water now. Okay, so we will actually place it into this thing. This is known as a round bottom flask. Okay, so let me just introduce to you some apparatus as well. We'll put it into a round bottom flask together with something known as a anti-bumping granules. Okay, inside. So this anti-bumping granules, right, the main job is to ensure that there is smooth boiling. During the heating of this mixture, it can be quite vigorous when it is bubbling and boiling. So that's why we add anti-bumping granules or anti-bumping chips, okay, or boiling chips. There are many ways to call it for smooth boiling. Okay, so you need to be aware of the purpose of the anti-bumping granules, because they will actually ask you. All right, so once this is done, we'll start to heat. Okay, so we'll start to heat the mixture. Okay, so naturally the water is going to vaporize, right? So the water will change from a liquid to a gas. Okay, so boiling takes place, liquid changes to a gas. And this gas, which is of course known as steam because you are dealing with water now, will rise all the way and reach the thermometer at the top. Okay, and once that happens, it will pass through this exit side arm into an apparatus known as a condenser. Okay, so I just want to focus a little bit about the condenser. Okay, let me just blow this up so that you have a clearer view of it. Now, there's two parts to the condenser. The condenser has a section. Okay, I'm going to color it in, not in blue. Let's have a different color, maybe purple. Okay, it has a section. I'm drawing this path in purple. This is the path in which the steam will actually pass through. Okay, but outside this path, okay, outside this purple path, there's actually what we call like a water jacket, okay, where there is actually a column of water that's surrounding this surrounding this purple path where steam will pass through. Okay, so what is happening is that, okay, in this water jacket, okay, there is actually cold water that is being pumped in from the bottom. I will explain why later on. And the cold water passes will actually surround itself around the hot steam that is passing through the purple path. Okay, and then the cold water eventually will escape from the top of the condenser. Okay, now what this cold water does is, right, it ensures that the steam will experience a cold temperature, okay, when it enters the condenser. And why do we want that to happen? It's because I want steam, which is in the gaseous state, to turn into water, which is in the liquid state, inside the condenser. So you will literally see steam condensing and eventually gets collected in when it exits the condenser. So the job of the condenser is to cool or condense the hot vapor into a pure liquid. Now, I like to use the word hot vapor rather than steam. Steam is only one specific case. If you are using a different solvent, you may not be getting steam. So, as the liquid that is being collected. So it is not right to always call it as steam. Okay, so hot vapor is a better choice than pure liquid. So likewise, I will not be using water all the time because it may not be water that you're collecting. Okay, so I hope this helps you to appreciate what the condenser does. Okay, now the other thing is, which I've not explained over here, why is it that we actually introduce cold water in from the bottom? Okay, the reason is because, right, if you know simple science, right, the key idea is this: when you have a cold body and a hot body being in contact, okay, the cold body will get hotter and the hot body will get colder until they reach what we call thermal equilibrium. Okay, so what the objective of the condenser is to allow, right, your hot vapor to experience a cold temperature, colder, and coldest, so that it will continuously condense and then eventually exit from the condenser to as a liquid. Okay, that's why when I first introduce the cold water, it must be in this region. That will ensure that the water here, okay, has not come into much contact with the hot vapor that is passing through the condenser. This region remains the coldest. Okay, by the time it reached this region, it would be of a slightly higher temperature already because it will have come in contact with more steam. Okay, so I hope you can appreciate where this comes from. All right, they will not ask you to explain, but understanding will help you to appreciate why cold water is in from the bottom rather than the top. Okay, so we are almost done. Okay, yeah, I already discussed this. What is the purpose of the thermometer then? Okay, all right, we have not done this part now. The liquid that is collected is called the distillate. So this is a new word. Okay, yeah, you will need to jot this down. Okay, the distillate. Okay, so you have learned residue, filtrate, distillate, and sublimate. Okay, there are 4 terms that you have come across right now. And finally, okay, what the thermometer does is that it measures the boiling point of the solvent that is being distilled over. So if the thermometer reads 100 degrees Celsius, it is time for us to place a conical flask to collect, because you'll be pretty much assured that you are actually collecting pure water inside. But the moment the temperature is no longer at 100, then you have to quickly remove the conical flask. Okay, because it's no longer the pure liquid that you want anymore, right? The thermometer should be placed at the side arm of the flask and not deep into the solution. Okay, maybe a bit of understanding over here. If your thermometer is placed inside the solution, then the thermometer will be measuring the boiling point of the mixture. It will give you all sorts of haywire values, because mixtures, as you know earlier on, it will melt and boil over a range of temperature. So you will never be able to capture a fixed boiling point from using the thermometer. Okay, so some industrial application, actually distillation is used very widely, right, to obtain pure water from seawater. Singapore does that as well, but it's very, very expensive, because you will need fuels to get the heat started, to get heat to boil the seawater. Okay, and Singapore is a country with limited resources, so we do not have easily available fuels like that. Therefore, it's not advisable. That's the reason why Singapore has other ways to obtain pure water, okay, or clean water. Distillation, or what we call desalination, removing salt, actually makes up a small percentage of pure water production in Singapore only. Okay, so with this said, we have completed. Okay, let me put it at the center. The 4 techniques of obtaining different components of a solid liquid mixture. If the solid is insoluble, there's only one choice: filtration. Okay, particles of solid are very big. They will not be able to pass through the filter paper, so they'll be collected as residue. Liquid will be collected as the filtrate. But it gets more tricky when the solid is soluble. That will give you a solution. Okay, so if you try to pour a solution through filter paper, everything will pass through. Okay, so it doesn't work that way. Then how do we decide? You will have to ask yourself a second question. Do you want the solute or do you want the solvent? So if you want the solute, you choose either evaporation to dryness or crystallization, depending on whether they will decompose or they will not decompose. Most of the time, I would say they will decompose. The only one in your syllabus that you should be aware that will not decompose is sodium chloride, which is our table salt. Okay, and finally, if what you want is not the solute, what you want is the solvent, then simple distillation will be your choice. In order to know that you are actually collecting the pure solvent, you should actually monitor the temperature of the thermometer very closely. Okay,